Hey everyone, today we're going to dive into AppArmor, which is this really cool security feature that's built right into the Linux kernel. AppArmor gives us something called mandatory access control, usually pronounced MAC for short. Now I know that sounds pretty technical, but it can actually be pretty straightforward, and I think you'll find it very interesting. So here's the thing, regular Linux, it already has file permissions. We can set who can read, write, or execute certain files. That's called discretionary access control, or DAC. And it works great for the basic stuff, but here's the problem. If we run a program as root, or if some application gets hacked, those regular permissions aren't going to protect us. The attacker basically would have free reign to do whatever they want to anything. And that's where Mac comes in. With mandatory access control, our system itself would enforce rules about what programs can or cannot do. And these rules even apply to root. So even if we run something with sudo, AppArmor can deny those actions. It can basically say, nope, sorry, you're not able to touch that file. It's basically an extra layer of security that catches things even when our other security measures have failed. AppArmor is super popular on Ubuntu and Debian systems, and one of the reasons why I like it is because it's easier to set up and understand compared to something like SELinux. So today I'm just going to walk you through exactly how it works, and we'll go through a couple of commands and an example of how to use it. Firstly, just to check if AppArmor is running on our system, we're just going to type sudo aa-status, and it's just going to let us know a couple of things here. These are all the profiles on our computer. These show how many profiles are currently loaded. Sorry, these profiles are basically just security policies for different applications. You can notice how some say enforce mode, complain mode. Enforce mode basically means that it's actively blocking things. Complain mode means that it's more like a practice mode. It's going to log what is happening, but it's not actually going to block or stop anything from happening. Super useful when you're testing something out because you don't want to accidentally break your system. With that, we'll get right into our next section about creating AppArmor profiles. Okay, let's take a look at an existing profile with AppArmor. To just find where AppArmor stores its profiles, we'll just go to the etc. directory, and then we'll just type apparmor.d, and then we can see that here. I had that pulled up before, but that's how you get to that. You can see here that there's a lot of profiles for many common applications. Let's just take a look at the man command, and that's the command that we would use to read manual pages in Linux. So we'll do this. Just do the thing. Okay, so here we just pulled up that profile for that man command. Here we can see a lot of features that it's using. We'll go over a couple of them. First, we can notice here that it says at the top, user bin man, that's the program being confined. And then underneath that, it starts with the abstractions or the base, which would provide many common permissions that the program would need. Below that, we can see some additional lines with this RMCX. What AppArmor is doing here is something called profile transitions. That is when man calls another program like gzip to decompress the manual pages or trough to format them. these programs would run under their own restricted profiles, and that's how that's being called here. If we look down below a little more, we should find this profile for man graph. This is a subprofile specifically for a formatting tool. We can see lines with R for read access. It allows reading from like here, user share graph, where the formatting data is stored, but it is pretty restricted. It can't be accessed, or sorry, it can't access random files on our system. Here's the profile for the man filter for decompression tools. We can see here there are some additional things. If it has a slash star with an R, that means it can read files from anywhere, but that's pretty okay because it can just read and decompress. It can't actually execute any programs or write data to any sensitive locations. The key security benefit that this provides is just a layered protection. Even though man would need to run different kind of helper programs to display manual pages, each of these helpers is confined to only what it absolutely needs. So let's say there was a vulnerability in this or anywhere, an attacker couldn't use that to execute like arbitrary code or access sensitive files. They'd only be able to read and decompress data. This multiple layers of security can limit what threat actors can do on our system. Okay, now we're going to go ahead and try to create our own AppArmor profile from scratch. I'm going to go ahead and write a simple bash script that tries to do something sensitive, such as reading the passwords in the shadow file. First, we're just going to need to go ahead and create this script. We'll just name it something, just script maybe. And then I already have the script written up here, so I'll just go ahead and paste that in. But basically what this is doing, it's going to attempt to read the password hashes in that shadow file. If it's able to, it's going to say success. If not, it's going to give us that blocked message. We'll need to make this script executable so that we can run it. All right, now that we've done that, let's just try running our script here. Script. All right, looks like it ran and it says success here right at the bottom. It was able to read it. This is what we do not want to happen. This is what AppArmor tries to prevent. Now we'll need to create an AppArmor profile to restrict a script like this from running and reading our password hashes. We're going to use the command aa-genprof, which stands for generate profile, and this tool will watch what our script tries to do, and it's going to try to help me build a profile to stop this type of thing from happening. So we're going to do sudo aa-genprof, and we're going to run it on the script. Okay, and then as you can see here, it's started in learning mode. We're going to need to run our script in another terminal while this one watches it for what it does. So we'll go ahead and just open up another terminal here, and then we're going to try to run that script. Oh, sorry, that's the wrong name. There it is. We're able to run it. Now we can walk through these things and choose whether to deny access or allow access. So here we go. We're going to want to inherit these this access here. Now we can see here's our profile. This is the capability that it's asking for, and we can choose whether to allow or deny or ignore these things. So most of these things are basic permissions. We're going to allow them because they're necessary for Bash to run. So we'll just press A here. I'll press A on this one, press A on this one, continue with A. But now we see here, it's looking at the path to shadow, and we do not want it to be able to access shadow. So we're going to click D for deny, and then we're going to save those changes. Now that that profile is saved, let's go ahead and check to see that our profile has been loaded. And click finish. We're going to type sudo AA status, and then we're going to try to grep test or script here. Let's see if it comes up. All right, well, we can't see it there. You can also see that I've made a couple of other tests, but ours is the top one there. Let's go ahead and make sure that it is actively working. Let's try to run our script now that we're here. Let's see what happens. There we go. And now it says blocked permission denied when trying to read from the shadow file. That's exactly what we want happening. AppArmor has stopped our script from reading that shadow file, and this is very good. This is what we want with our profiles. This is what profiles allow us to do. So the question is, why does this matter in the real world? Why does something like AppArmor or mandatory access control matter to us? Imagine we download a program from the internet, or you're running a web server. Even if that program has a security vulnerability or gets hacked in some way, AppArmor is going to limit the damage an attacker can do. For example, let's say if a web server gets compromised, an attacker might try to read your passwords to find usernames or to access user files. But if we have a good AppArmor profile that is watching for that, that is blocking that access, the web server process is going to be confined. It can only access the specific directories it needs for serving our web page and nothing else. This is very important for servers and systems that are exposed to the internet. It just adds an extra layer of defense so that even if one security measure fails, we have another protecting us, and in this case, it is AppArmor. So just to summarize the key AppArmor commands that we need to know, there's AA status to check what's running. We can run AA enforce on something to turn on strict blocking. There is AA complain to put profiles in a learning mode, and AA disabled or disable to turn off a profile. AppArmor is easier to use than SELinux, which is why it's defaulted on Ubuntu and Debian systems. It is path-based instead of label-based, which makes it simpler for us to understand and configure in a way that helps us protect our systems. The most important takeaway here is that AppArmor gives us that mandatory access control. It gives us the ability to enable policies that limit what programs can do even when they're running with elevated privileges. It's a very powerful tool, and it's very useful for securing Linux systems. If you have any comments, feel free to reach out. We would love to help you understand more.